Alright, you can start.
Hello and welcome to Software Architecture course. In this lecture, we will talk about object-oriented designs. So, object-oriented design is not really a part of architecture, but this particular lecture is primarily meant for the completeness, because during the architecture phase, you will be creating not just the architecture, but also you will create a lot of prototypes, a lot of scenarios, and as an architect you will be an important person for the design team, who will be designing based on your architecture, and they will be actually using the object-oriented design. So for the sake of completeness, we will talk about object-oriented design, and we'll talk about UML model, because this UML model is one of the essential tools that the architect should use. And for the O design, so we should not really expect that this particular class is going to really cover the very detailed nuances of object-oriented design. It's just a high-level design, and as I said, it's primarily for the sake of completeness. So we will start with one example, which is an online shopping application. We call it as Pet Store. This was quite popular, and now it is available in Oracle website created by Sun Microsystems. It actually has a reference architecture for people who want to understand J2EE based application development. So, and this could be a good example to illustrate various features of a distributed system and architectural elements. So, very briefly, Pet Store actually has a component called Storefront. So, Storefront is the main user interface, which is a web-based front end. So, customers use this Storefront to place various orders for pets, and pets like fish, then cat and dog and so on. So this particular Pet Store is online store to sell such pets over the web, and there are various requirements or features. For example, on the storefront, one can do the registration, then login, then browsing the catalog for products, then place the order to the order processing center, and placing the order to the OPC is basically done through asynchronous messaging, and this OPC receives an order from the storefront, and then it processes the order. Then there are administrators who is and that particular role, administrators could be one or more people, but that particular role is responsible for examining various pending orders, approve or deny a pending order. Then there is an entity called supplier, which is outside the scope of Pet Store, but Pet Store application would interact with supplier. So supplier will view and edit the inventory. Supplier would basically fulfill the orders from the OPC, from inventory and invoices the OPC. So given this toy application, let us look at various system qualities that we have learned so far: availability, modifiability, performance, security, testability, usability, and interoperability. And let us see what could be the various quality related requirements that we can imagine for this storefront. So for example, one requirement could be to show the orders in multiple languages. Now clearly this particular requirement is related to usability. Help in browsing products, that's also a requirement for usability. Obviously help in browsing products is not a very good quality as far our quality requirement capturing process. So we learned how a quality requirement can be captured using scenarios. So this really does not fall into that, but this is just a one-liner to explain what kind of qualities that are possible, and if someone wants to really capture this requirement seriously, then just one line is not going to be sufficient. One has to really elaborate what's meant by help. Similarly, easy checkout is also a usability requirement, but again, easy is a quite vague term. One has to elaborate it. Assurance to customer, supplier, and bank that the transactions are all faithful and correct. This is clearly a security requirement. Delivery is guaranteed. Again, it is about both security as well as availability. Shopping cart is only modified by the customer. That's again security. Order never fails. That's about availability. System is always ready to sell. That's also availability, and so on. Order processing takes 2 seconds. It's a performance requirement. And there could be many such quality requirements, like system always optimally use the hardware infrastructure, and it should perform the load balancing. You can guess what could be the quality for this particular requirement. Usage of standard protocols to communicate with the suppliers. This is interoperability requirement. Usage of secure electronic transaction protocol or SET protocol for credit card processing. You can now guess what could be the corresponding quality. Quite easy to add a new supplier. This would be, again, you can guess what would be the system quality here. Little change is necessary to add a third-party vendor. Quite easy to sell books in addition to pets. So what that means is that right now the pet store is selling pets, but tomorrow there is a new requirement to essentially sell books as well in addition to pets, and it should be quite easy to add books in the system. Logging is extensive to trace the root cause of the fault. You can guess what could be the system quality, and so on. So there could be many such system quality requirements. So programming for this application, essentially one would typically do object-oriented programming. Here everything will be an object: pet, customer, supplier, credit card, customer's address, order processing center, everything is an object. Pets can be sold, credit card can be charged, clients can be authenticated, etc., and orders can be fulfilled. So which means that these objects actually have behavior and they have properties, and they interact with each other. For example, storefront places order to the OPC. So what's really the good thing here is that these objects like pets, customer, etc., they are very close to the problem domain. So therefore object-oriented programming helps architect to basically relate the solution, or rather get the solution verified with the domain experts easily. So domain experts can really pitch in easily because the objects are quite close to the problem domain. This is one of the good advantage of using OO programming. And one could group features and related operations together so that things are all modular. It is possible to add new types of pets, for example, adding birds in addition to cat, dog, and fish. That's possible if one can do a good object-oriented design. So in a object-oriented design, let us look at what is a class. Class essentially represents an abstract user-defined type, and class actually has two parts. One is the structure part and another is the behavior part. So the structure essentially defines the properties or attributes. They are commonly known as member variables if you are using the programming languages like Java, C++, C#, Python, and so on. Behavior is operation specification. Essentially, behavior means that the class will also have a set of methods or member functions, which will essentially manage or modify these member variables, and typically the interaction with the object happens through these methods. So essentially, what's the difference between an object and the class? An object is nothing but an instance of a class. It can be instantiated or created without a class, meaning that an object is an object actually has a type, and the type is the class, and it can be instantiated, meaning that it can be created. So while creation, you can just say that create an object of that particular class type. So states, object actually has a state. Class really does not have a state, but object has a state. So let's look at what are those states. Essentially, the state means that the properties and attribute values at a particular moment during runtime. That's very important. Object state is meaningful only when the object is existing, and object exists only when the program runs. So when the program runs, the object is created and object attribute values are present, and those attribute values actually represents the state of an object. Object may or may not change the state in response to an outside stimuli, and that outside stimuli is essentially a method call. And objects whose state cannot be altered after creation, they are called actually immutable objects. And the corresponding class is called an immutable class. For example, the string class in Java is immutable class. What that means is that once you create a string class, when you create a string object from a string class, then after creation, its state cannot be changed. Its attribute values cannot be altered. And objects whose state can be altered after creation are known as mutable objects, and classes are also called mutable class. For example, string buffer class in Java. So string buffer class is a mutable class, and object of string buffer class is a mutable object. So essentially, let us just step back again. So we have these three instances of the dog class: Labrador, Golden Retriever, and Pug. These are all instances of the dog class, and their attribute values are age, price, and sex. And so these values, like Labrador 1 year, 3,500 rupees, and male or female, so these values actually means that this object has a particular state. And if you change the age from 1 year to 1.5 year or 2 year, then we say that this object's state has been changed. So object-oriented programming is so essentially a program is a bunch of objects telling each other what to do by sending messages. That's a general definition, but when you are using programming languages like Java and class, there is nothing called sending a message. What happens is that an object basically makes a method call, and that method is executed. So object O1 calls a method of object O2. So that's what is the case in Java, C, C++, and C#. And you can create any type of object that you want. Now, so one of the questions are that is object-oriented programming, is it different from procedural? So one group of basically people who are basically, if you look at it from the computer science perspective and basically think about the theory of programming languages, essentially at the end of the day it is not different at all, because every reasonable language like Java, C++, or C, or even Fortran, they are ultimately the same. They are all Turing complete languages. But on the other hand, if you look at from the other perspective, it is very different if you really want to build a large system, because in using O program you can build really large systems, which can help you to basically improve the understandability of the program. We are talking about programs which are multi-million lines of code, at least several thousand classes. So there, in such a complex scenario, object-oriented programming actually helps in understandability. Less chance of committing errors because the understandability is very high. Makes modification faster because objects are all grouped, and if the grouping is done properly, then modifications can be really localized. And compilers, the modern compilers in Java and C++ actually can perform quite strong error detection. So let's look at the type systems. Classes are essentially the user-defined data types, and there are other primitive types as well, like integer, float, character, then Boolean in Java and Boolean in C#, double, short, long, and string. String is a primitive type in C#, but it is not the case in Java. String class is not a primitive type. There are unified types. For example, C# uses a keyword called object, which is the mother of all the types, or root object. Essentially, is everything, including the primitive types, are objects. But that's not the case in Java. In Java, there is a clear distinction between the primitive types and the user-defined types, and they do not have the same root, unlike C#. Java JDK gives a Java lang object, which is definitely not a part of the language, whereas in C# object is a part of the language. Let's look at values and references, a very important concept in object-oriented programming. So primitive types are typically are actually accessed by value. For example, C++ allows a variable to have object as its value. Now that's not the case in Java though. Java does not allow a variable to have object as its value, but C++ does allow it. C# uses struct to define types whose variables are values, and when objects are actually defined as a value or accessed by value, then no explicit object creation deletion is actually required. So this process is quite faster, and the space is decided during compilation time, and it is quite fast at the time of execution. So Java allows a variable to have to be accessed by a reference. So essentially, when in Java, if you are actually using a primitive type, then of course it is accessed by value, but otherwise, if you are dealing with objects, then it is only through reference, meaning that in Java you have to create an object using the new construct. That is true for C++ also when you are using a reference. And C++ uses pointers for reference, which was actually taken from its mother language, which is C. And in the case of references, you need explicit object creation. It is slow because the space is allocated during runtime, and it is allocated from the heap. Java actually sometimes performs escape analysis for faster allocation. In the escape analysis, sometimes it tries to essentially create the object in the stack as opposed to heap. Let's look at the modules. Now this is how you are going to actually have you are going to really create a proper design and proper modular structure. Now these modules would be synonymous to the module structure that we have learned in software architecture, specifically module structure. And if you recall, I was saying that architect would basically translate the module structure, and then it will create the code structure from module structure. It is going to hand it over to the design team, So essentially those module structures will be mapped to files, folders, and also the modules in the programming language. So this module and that module would have a direct relationship. So here, you need an organization when you're really dealing with a large body of software, which is maybe 20 million lines of code, having 30,000 classes or files. You just can't have it, in one directory. At least you need to organize them into meaningful modules. And as I am saying it again, that these modules will be related to the module structure that the architect has already created. So, but the notion of these modules were actually introduced. It was introduced much earlier in 1970, and the notion of module that time, and it is true even today, is essentially grouping the similar functionality together is the basic concept. And at that time it was first proposed that there should be an interface, and implementation should be hidden from the interface. Earlier languages like Modula, Ada, etc., they all introduced this notion. In object-oriented languages, class became synonymous to a module, but unfortunately class has become quite fine-grained. As a result, such implementation and interface, though it exists at a class level, it becomes quite tricky sometimes, because if the class is quite fine-grained, then the whole purpose of modular design, where the number of modules would be much less. In that example of 20 million line of code, maybe the number of modules could be around 200 or maybe 300, not more than that, maybe 400. That's it. So ideally there should be an interface related to a module, but unfortunately the languages today like C++, Java do not really support that. They actually thought class to be a really coarse-grained element, and they thought class could be equal to module, and therefore they kind of propose this interface and implementation for a class. But today we all know that class is not synonymous to a module anymore. So nowadays ANSI, C++, Java, Haskell, C#, Perl, Python, and PHP, they all support the notion of module. They use a term called namespace and package. And there are some modular properties in namespaces as well as packages. We'll focus on the module a bit, because this is more architectural in nature. So a set of classes are grouped into a module. A module can be decomposed into a submodule, and it actually creates a containment hierarchy of module. Now you can now clearly see that how it is related to the module structure of the software architecture. A fully qualified unique name is basically the module name plus the name of the class. So a fully qualified unique name for a class is you have to append the module name and submodule names and so on before the class name. Importing is a notion where a class can selectively use one or more classes in a module, or import the entire module. Now please relate this with the module structure again, where we learned a relationship called uses. A module uses a feature of another module or functionality of another module. This is what it is. Here, if you are creating a class, you can basically import. You are creating a class inside a module or a package, and what you do is inside the class you import selectively one or more classes from another module. Obviously, if you are using the class in the same module, you don't really do this import. You are doing the import only when the class is outside the current module, where the in the class in the context is actually residing. If a class A is going to use a method of class B, and then if class B is not in the same module of class A, then class A will have to import. This is what I'm saying. So now let us look at some of the other features of object-oriented programming. And one of the key concept is inheritance, and we need to learn this because this is one of the very important feature that as an architect you need to understand and practice it very well so that you can make your system extensible. You can add features, you can extend new features, you can improve modifiability using this technique. So inheritance is something that one needs to really understand it well, and specifically architects needs to understand it very, very well. So it's if you have already done a course on object-oriented design or software engineering, you are familiar with it. And what I'm trying to do here is I'm trying to emphasize again that from software architecture point of view, why you need it. So let's look at the definition of inheritance again. There is a parent class called base class, and there is a child class or a children classes which are called derived classes. So a derived class inherits the methods and member variables of the base class, which is also called is-a relationship. A child can have multiple parents, which means it can have a multiple inheritance. That's possible in some programming languages like C++, and also in Perl, but this is not allowed in a programming languages like Java. And but one property is very important, is that this hierarchy of inheritance is basically a directed acyclic graph. What that means is that if you imagine that these classes are the nodes and the edges are basically the inheritance relationship, then what you get is basically a acyclic graph, not without any cycle. So there cannot be any cyclical dependency in the inheritance. The derived class can use inherited variables and methods, which is called the reuse, and it can add new methods, which is essentially extension or extending the functionality. Modify a derived method, it is called overriding the base class member function. So modification, adding new methods, etc. are possible, or even reuse it as it is. So these things are possible, and these actually play a very crucial role in improving modifiability. What is an interface? Interface is essentially a published declaration of a set of services. Essentially, an interface is a collection of constants and method declarations. No implementation is there. A separate class is required to implement an interface. And a class can implement one or more interfaces. So why we need interface? We need interface because it provides the capability to for unrelated classes to implement a set of common methods. That's the reason why I would require an interface, meaning that there could be a set of common methods, a set of common features that I want to be implemented, and this is a technique by which I can have a class which can do other things, but at the same time such common methods are also implemented, which is the reason why a particular class can implement multiple interfaces. So each interface is basically exposing one type of or rather one interface is exposing a set of services which are kind of similar. Example is that if you are basically creating, let us say, a class which is, say, dealing with network communication, okay, and then you can expose an interface which basically contains a set of methods related to interface which is related to the network communication. But it can also do some additional activities as well. But if you expose this interface, which is if you have this interface associated with this particular class, and if another object which if that object basically takes the interface which is a network related interface, then that particular object can only access those network related features or methods. So to that particular object, this class which is implementing the network interface, essentially for that particular class, it really doesn't know that what this particular class is actually doing. But hello? Huh? ঠিক আছে, আমি একটা ক্লাসে আছি, এখন। We have to redo that again. Shall we redo that?
This slide, yeah.
Yeah, from this particular slide.
Okay.
Shall I start?
This is earlier slide, right?
Huh?
This is the next slide or the earlier slide?
No, the slide that you see right now, that's the slide I have to do a retake.
Yeah, okay, fine.
So let us introduce the interface. Let's understand what this interface is in the context of object-oriented design and why it is required. Essentially, an interface is a published declaration of a set of services. An interface is a collection of constants and method declarations. And important thing is that an interface does not really provide implementation. It basically it's a technique by which it separates the method declaration with the method implementation. So one needs to have a separate class to implement an interface. Of course, in C++, that's also true, but what happens in C++ is in one class you define this declaration and in another class you provide implementation. In Java, it uses something else called interface, and an interface is not really a class. So a class can implement one or more interfaces. That's important. And why it is required? Because with this, when a class implements one or more interfaces, then it allows a set of unrelated classes to implement a set of common methods. So there could be a set of common methods, and then it gives a flexibility that an unrelated class can implement this interface. And this is actually a very, very useful feature, specifically in the GUI programming, where a particular class can act as let us say event listener by implementing the event listener interface. But that class is really not just event listener. It can do many other things, but it can also act as an event listener. So this is what is meant by an unrelated class can implement a set of common methods. It can standardize interaction. It can provide extensions so that the designer can defer the design later on. It can just provide interface, and that actually helps in building a large piece of software by a group of people in parallel, where as soon as the interface is designed and it is frozen, even though the implementation takes time, but the other team can actually assume that the interface and assume the functionality and then go ahead with their own design. A user does not know who implemented it, therefore it becomes easy to change an implementation without impacting the user of this particular class. So an interface in C++, C Sharp is basically a class that has at least one pure virtual method. A pure virtual method has specification but no body. This is called abstract base class. One can have an abstract base class where some methods are concrete and some are completely virtual, and other class needs to implement that. But in my opinion, such a design is quite clumsy. Java uses a more clean design, which is called, they use a term called interface. So interface only provides method declarations. Java also allows to define an abstract base class like C++, but for a pure interface, it is essentially it's much more clean compared to C++. Creation of object is a very important as concept in object-oriented design. As an architect, this is also an important part because creation of object has got direct impact with performance. So therefore, as an architect, when you are designing a framework or you are planning for a high performance system design, you need to take care of creation of objects. You need to do it, you need to create it judicially. So these are called architect's decision. So creation of object plays a very important role. With built-in types like integer or character, we can just say that integer I or character C, and we basically get those variables directly. We get the variable C, we get the variable I. When we define a class A, which is a user-defined type, we need to explicitly tell that we want a new object of type A. We use an operator called new in that case. We initialize the object after the creation, and that initialization is called a constructor method. That is there in both C++ as well as in Java. A special method, it's a very special method that compiler understands. The constructor method name must be same as the class name. That's very important. And C++ allows the constructor method for struct also. But however, in Java, such concept of struct is not there. Now, constructor method can actually be overloaded. That's there both in C++ as well as in Java. Like construction, destruction is also an important feature because when you construct an object, the memory space is allocated from heap, which is a time consuming activity. And as I said, that as an architect, you need to be providing some design guidelines. You need to have some design decisions which the designer should follow. Similarly, for object destruction also, as an architect, you need to take a decision so that the overall performance of the system is not hampered by object destruction. There is another important role here for an architect, which essentially the designers will also have to follow, is that if the object creation and destructions are not happening properly, and if you are building a system which is going to run for a long time, meaning that it should be available for a longer duration, and that's typically an expectation for any serious application, then you need to take care of something called a memory leak. So memory leak is basically a phenomenon where when an application runs for a long time, and because of the programming mistakes, the object is not destroyed and returned back to the heap. So as a result, those objects keep accumulating in the memory, and their traces are lost. So those are not returned back into the heap. It stays in the memory, and then gradually the heap becomes completely exhausted and the application fails. So this memory leak is a very it's quite common phenomenon, but it is something that every architect has a nightmare to basically remove this, and that creates problem when the application is in production. Therefore, object destruction is directly related to object creation. As an architect, you need to understand this in great details. So if an object goes out of scope, it can no longer be used. Essentially, its name is no longer known, but it is necessary to free the memory occupied by the object. Please understand this part very well, that when the object goes out of scope, it cannot be used. Therefore, there is no way you know if where that particular object is, but that memory is still occupied and it is not returned back to the heap. And if this phenomenon continues, then it becomes a memory leak. Just before freeing the memory, it is necessary to perform a set of cleanup tasks that one needs to decide. So these set of cleanup tasks are actually a part of destructor method. Special name for the destructor method is tilde class name in C++, but in Java there is no explicit destruction. It happens. It is taken care of by the Java runtime. But Java provides a method called finalize, in which some cleanup activities can be put. Freeing the memory is explicit in C++, which means that it can give the programmer an ability to get rid of the object that the program does not need. However, if the programmer is novice, then there is always a chance of having a memory leak. Java uses a reference and a garbage collection technique to do this automatically. So in this class, we have basically learned about the basics of object-oriented programming, and that will be the basis for the UML. UML is, as I said, it's a tool that's used by architects very often, and you need to be familiar with UML. You need to be familiar with the tools like Rational Architect, or you need to basically, if you're using some other freeware or other companies' tools, they essentially all implement UML 2.0 today, and you need to use those to basically describe architecture as well as the design. Thank you very much. We will we'll learn about UML in the next class.
All right.
So